akkor szólítanám Thomas Schulz urat, aki Berlinből érkezett el, és egy barcelonai eseményt cserélt le a Smart Factory ConnAction-re, úgyhogy ezúttal is köszönjük, hogy eljöttél. Kérnék szépen kitenni a prezentációt, már itt is van. Ezzel fogsz tudni nyomogatni. Ezt a mikrofont ja, neked van mikrofonod?
Nem, van már.
Az egy menőbb mikrofon. És akkor, ha jól tudom, akkor adatelemzésről fogsz beszélni arról, hogy folyamatmérnökök hogyan tudnak üzleti értéket teremteni az ipari adatokból. Magyarul vagy angolul?
Angol.
Angolul, jó. Köszönjük szépen.
Köszönöm. Beszélek valamennyit magyarul, de már nem olyan jó érzem magamat, mert most két éve, tavaly itt voltam, de régen itt jártam. So let's switch to English. In industrial analytics for process engineers, this is the topic. And the question is, why is it so important? So industrial analytics, process engineers, a lot of people are speaking about analytics. You heard today big data, doing more with the data, with the information. But the question is, how does it work in the industrial environment? Let's have a first look. What is analytics? Analytics is a very, very nice description, discovery, interpretation, and communication of meaningful patterns in data. This is analytics. Why we are doing that? We heard that already in the presentation, before my presentation. You want to do more effective decisions. You want to do the decisions much quicker. You want to bring the data from the shop floor in the boardroom. And this is the reason why. So you want to do more with the data, and then you need the analytics. And for sure, if we're doing that, this is a very generic description for improved business performance in general analytics. And industrial analytics, you want to improve your production, your processes, whatever it is. If you're producing a car, or you're doing something else in the process industry, or you're producing some life science, some medical things, whatever it is, you want to improve the performance of the business of your production. And this is analytics. Let's see again, the next slide. What does it mean? We heard already, predictive. What is that? Prescriptive. We also heard, yes. What is it? So it is always, hopefully you can see it, it's always the same. You have the data on the one side, and on the other side you have the actions in your plant, in your factory. And in the middle between, you have the analytics. These are the tools, the frameworks, the software, what is supporting you. And you have the human input. So you also have to do something. And the very easy, or the first step is very easy step is descriptive. You want to see what happened. It's quite easy. You're collecting the data with an historian software like we have, or with something else. Doesn't matter. You're collecting the data, and you're looking to the data. You have the time scale, and you have the pressure, the temperature, whatever it is, or the alarms, and even you see that, okay, this happened. What happened? This is very easy. And if you're really looking, before you're coming to a decision to do something, people are doing a lot of things with this data, and the most common tool or framework is Excel, I believe. Everybody is using that, putting data forward, backward, and spending a lot of time to do something with the data. This is a very first step, and really the first step of the analytics. But is this enough? No, I don't think so. If you have the data, you see the temperature, you see the pressure, you see it, you're a process engineer, you want to know the diagnostics. This is the next one. Why did it happen? So why is this product not so good like the other one? What is the reason? And this is not so easy, not only showing the data. You need a kind of digital twin behind it. We're calling the digital process twin. Because, and now coming back to engineer, you think really that the managing director knows what is the reason that the product last week was bad? No. These are the process engineers. They know what can be in general the reason that the product or the result is not good. Why did that happen? And you're building that in a kind of digital twin, and then you're going forward. These two things are looking backward. So you're looking into the past. The next step, you heard it already, predictive. What will happen? So then you have the digital twin, And you're moving the digital twin each closer to the reality with iterations again. You're doing that, then you think, okay, now my digital twin is very closely to the reality. And then you can really find answers to the question, if I'm driving this process like I'm driving it now, what will happen in the next 3 hours? What will happen in the next 4 hours? What will happen? And then you can plan the future. You see, the analytics are taking much more over activities and things from you, and the human input is smaller. But you're still you doing the decision, and you're doing then an action. And the prescriptive, this is the last one, what should I do? This is not only what will happen, what should I do, that this can happen. So this is decision support. This is the first step. The system is telling you, hey, you have to do now this and this and this, otherwise your process will crash. And the decision automation, everybody knows it from the autonomous driving a car. Then we are calling that in the past advanced process control. Then the system is taking over the control of the process. And you see, there is no decision from you. There's the action is coming, and this is done. And if you really see that, this is a process over steps, over a lot of steps, and you can build up the knowledge. You're starting with diagnostics, you're coming to predictive, and then to prescriptive. This is the things how it works in general. Okay, Proficy CSense, I believe Schulz is here. He's one of the best experts in Europe. CSense is one tool, is a framework supporting you. And you heard it already, no coding. This is also a no coding, low coding framework. You don't have to be a programmer. You can put the things together and then you can do the first analytics to combine data from different sources, to discover root causes, to optimize things. So this is what we are offering as a framework. Proficy CSense. Don't forget it. We have a lot of applications all over Europe, but also in Hungary. Once again, what is this software doing? So you have the unknown knowledge in the data. You have somewhere, you remember on the ones there was the data, you have the knowledge there. Okay, it's fine. But you, now coming back to the process engineers, you have the process knowledge, not the data have that. You have that. You know, if this temperature is high, you know what can be the reason, the pressure or whatever, you know it. And these two things we have to bring together with this CSense software, knowledge fusion, and then you're coming to a solution. And this is the reason why, if I'm giving this tool, is a hybrid process, to somebody who's coming from the IT and don't understand the process, he can handle that, but you don't know for the temperature, coming back to this issue, what can be the reason, because you don't know the process. And this is the reason you need both. You need the process knowledge from the process engineers and the knowledge from the data. And for sure, if you want to do something, you have at first to collect the data, because if you have no data, it's difficult. If you have no data from the past, you have maybe your knowledge, but you cannot use it. Okay, this is a little bit the things. This is what we are doing. Normally, you have a standard deviation. This is a Gauss curve. And you have a process, a specification curve. And you see is up and down. This is a maximum limit. And what you're doing with CSense at first, you're reducing that, coming to whatever, 6 sigma, if you like. You're reducing that. And in the next step, if it's stable, then you can move it closer to the specification maximum limit to get a better output. This is in general what we are doing with some slides. Okay, how we are doing that? I need now, I see the time is running out, I need at least 30 minutes additional time to explain what we are doing. Analyzes, monitoring, analyzes the root causes. This is the first one, and is coming the early warnings, reduced downtime and waste. When we're doing the proactive actions, do you remember the prediction is the next step? Simulation, the process digital twin, what else? Simulation you can do. This is the next step, and the optimization. For sure, I'm not able to speak about all these things here, but I have my colleague here, Dennis Reimann. He's sitting at the GE booth. He can really show you that, how does it work. And I'm only going very, very roughly into the first one, root causes. Everybody knows root cause is a method of problem tackling and solving. So you know, okay, something is wrong, but what is really the reason? I believe this is a good picture, understanding root causes. You see the symptoms, the result of the outcome, the problem you see. Maybe the problem you also can define, okay, a gap from the standard, something is wrong. But the causes, they are under the earth. You don't really see it, to be honest. The roots, the system below the surface. So what is really the reason that my result is not good? And this is the first step where the system is supporting you. You have a result, you have a primary causes, a secondary, a tertiary, and so on. And this is not only in this way. This can have an impact to the result. This is very complex. And for sure, if you're a good process engineer, 40 years in the work, next year you will retire, I believe you can do it without a system based on your experience. But normally it's better to have a system support like CSense. You're loading the data, you're combining the data, to preparing the data. Even data preparation is a very, very huge topic. I don't have time to touch it. But this is the next one, and you're coming to the root causes. So you see here, I will switch it very quickly because we have the live software here. So you're loading data somewhere. You see, this is very, very easy. This is a histogram, a scatter plot. You have the process statistics. Everybody knows you have the trend lines. You can select all the areas where you see, oh, maybe the sensor was wrong or something was wrong. I will deselect this area of data because it's not good. It's not representing my process. You can do it. And these are examples. You see also the topics here, the steps, data preparation, very, very similar, low coding, no coding. You're going to the things and you're doing something graphical, interactive. Whoops, I believe this is one real example. Let me see, what is it? And you see there the causes analysis. The system is telling, you're telling what is the input, what is the output, and what are the possible things having an impact to your process. And the system is telling you, hey, I know this use case. This is roller speed. This is one of the examples what I have here. And the system is telling you, hey, this item have a very, very big impact to the whole process. This is a real project in UK, what we did. You have output, red, and model output, and then you can compare it. It's really better to see it live. I have 1 minute left. This is a decision tree, okay, starting from the top. And you have the possibilities, and you have the next level, and then you really see, okay, what can be the reason for my bad quality, or what is the reason, what can I do to have a better quality, or to improve something. This is the result. Finally, you see the histogram, you see the optimized histogram, and you see the process, how it should be. This is a very theoretical example, and the red one is a real process, and the blue one is the optimized process. Doesn't look like this, that you have only one, but this is one of the results what the system is giving you a benefit estimation. 1 minute is left. We have two examples. One is Herning one. This is an example from the wastewater industry from, sounds like Denmark, but however, hopefully yes. We have a partner in Denmark very active in this, and he really did some improvements. I have only one slide here, but we have a brief description for this use case. This was a prime effort with the roller speed tortilla chips. What we really have, I presented 3 years ago at a conference in detail. So this is really one, how you can, the task was how you can compare two production sites, one in UK, one in US, and they did it with both sides to see what is the reason for having a better quality. And this is the last one. If somebody from you is really good in speaking German or reading German, not speaking, we have analytics in the industry, key technology for digital transformation. We have a book. This is also available as an ebook, free of charge. There's a link. It's also in the PDF, the link. You can register, you can download. And a little bit what I explained here, what are the methods of the analysis, my first slide. What are you doing with the data analysis, process chain, what is machine learning in general? Everybody's speaking about machine learning. It's not so complicated. This is really descriptive. What is that? The role profiles. What you need, process engineer, IT, what you need really to set up a project, what the kind of skills you need, what makes sense. Success factors for application. This is from Dennis Reimann, he wrote it. So what are the things really what you have to understand as a process engineer? We have 3 use cases there, analytics use cases. One from Austria, one from Denmark, and one, I believe, from South Africa, and some categories. This is 100 pages, very nice book, free of charge. It's an e-book in Germany. We're still looking for translation, for sponsoring the translation. If you're interested, go to Peter Bohner to have it next time. Thank you for your attention.
Köszönjük szépen, Tomasz, a könyvnek a fordítását még később megtárgyaljuk. Van-e kérdés? Most magyarul lehet kérdezni?
Persze lehet magyarul.
Adatelemzéssel, szoftver környezettel kapcsolatban van-e kérdés?
De még ott ülünk, ha valaki meg akar nézni, élő a szoftver, ott lesz a Dennis, ő az expert.
Jó, akkor, ha nincs most, akkor majd később lehet akkor tőletek kérdezni a standon. Jó, köszönjük szépen Thomas Schulz úrnak az előadást.